Okay, welcome math students. Today we are going to talk about and figure out how to find the distance between two numbers. So let's say on a number line we have, let's draw ourselves a little number line here. Start at 0. That looks ugly. Let's say our 2 points, our two numbers are 2 and 6. So we can count the distance between 2 and 6 just by like hopping to the next number. So from 2, we go 1, 2, 3, 4, and we get to 6. So the distance between 2 and 6 is 4 because we counted 1, 2, 3, 4 spaces away. But what if we have our two numbers are something like 24 and 156? How are we gonna find that efficiently without counting 1, 2, 3, 4, 5 and like counting all the little hops in between 24 and 156? Well, so there's actually a formula for finding the distance of something. So this, oddly enough, is called the distance formula. The distance formula is this. It is the absolute value of P minus Q. If you are like, what the heck, Mrs. Williams, I thought I was in math. Don't we use numbers in math? Where did this P and Q business come from? The P and the Q, those are variables. I think I spelled variables right. Those are variables. They represent any number you want them to represent in a problem. So P, we can assign a value to P, we can assign a value to Q. They're just, instead of, because we don't know like what numbers we're gonna come up with, they're just placeholders for now. And when we talk about variables in math, they're letters that represent numbers. Letters that represent numbers. Okay. So if we look back up at the first example that we had, where we had 2 and 6 up here, back up here, we can figure that out using the distance formula. We're going to take the absolute value of 2 minus 6. That is a subtraction problem, so we're going to use a rule of subtraction, and we're going to keep the 2, change the subtraction to addition, take the opposite of 6, which is going to be negative 6, and now it's an addition problem. And so 2 plus negative 6, using the rules of addition, we get negative 4, and the absolute value of negative 4 is 4. So that is the distance between 2 and 6 using the distance formula. So let's go back and look at this one, 24 and 56 and 156. Let's use the distance formula. Let's give ourselves a little bit more space here. Let's use the distance formula. I'm going to do it in a different color. 24 and 156. We're going to take the absolute value of 24 minus 156. And that's a subtraction problem, so we're going to use a rule of subtraction, which is keep 24, change the subtraction to addition, and take the opposite of 156, which is going to be a negative 156. And then we're going to use the rules of addition, and these have opposite signs. So different signs subtract and take the sign of the higher number. So I'm just going to do it over here on the side. 156 minus 24. 6 minus 4 is 2. 5 minus 2 is 3. 1 minus nothing is 1. So we've got 132, but 156 has the higher absolute value. So we're going to do absolute value of negative 132, which is just 132. So the distance between 24 and 132 or 156 is 132 steps away. So now I want you all to look in your Module 2 book. We're going to be on page 35. Let me go to page 35. And we're going to look at example 2. I'm just going to rewrite the distance formula up on the top here. Absolute value of P minus Q. And remember, the P and the Q represent numbers. Example 2 says, distance is positive, but change in elevation or temperature may be positive or negative, depending on whether it's increasing or decreasing. Okay, so anytime there's a distance between two things, it's always positive. We can't really have a positive or a negative distance, like it's not negative miles away from something like that. But change in elevation or temperature, it can go up or down, and we'd show that by assigning either positive or negative to it, okay? So let's look at A. A hiker starts hiking at the beginning of a trail on a point which is 200 feet below sea level. He hikes to a location on the trail that is 580 feet above sea level and stops for lunch. What is the vertical distance between 200 feet below sea level and 580 feet above sea level? Okay, so the first thing we need to do is translate these descriptions of 200 feet below sea level and 580 feet above sea level into integers. So I'm going to draw this little scenario out. This little dude or girl, dude, or I guess dude can be gender neutral depending on who you ask. He starts hiking at a point which is 200 feet below sea level. So let's label sea level. Let's say that it's there. We're going to call sea level 0. And 200 feet below sea level, I'm going to put here. And 580 feet above sea level, I'm going to put up here. So 580 feet above sea level, that's going to be a positive 580. We don't need to put the plus sign, but I'm doing it just for the sake of showing you that it's positive. Now, 200 feet below sea level, we're going to indicate with a negative. So when we say 200 feet below sea level, that is negative 200. We're going to use the distance formula to figure out the vertical distance between 200 feet below sea level and 580 feet above sea level. So we're going to take the absolute value of negative 200 minus 580. Now, let me get these numbers here out of the way. This is a subtraction problem, so we're going to apply the rule of subtraction. Keep negative 200, add, and the opposite of 580 is negative 580. And this is now an addition problem. So the rule for adding numbers with the same sign is add, keep. So 580 plus 200 is 780, and it's going to be negative because we're keeping the same sign, and the absolute value of negative 780 is 780, and that is feet. So the vertical distance between 200 feet below sea level and 500 feet above sea level is 780. Okay, how should we interpret 780 feet in the context of this problem? Well, the problem was talking about a hiker who hiked from the beginning of the trail down here to the end of the trail up here. So we can say that 780 feet is the distance the hiker hiked. Or something else like that. Like the hiker hiked 780 feet from a point, from the beginning point to the end point. So, or he hiked from below sea level up 780 feet above sea level, or something like that. Okay. B. After lunch, the hiker hiked back down the trail from the point of elevation, which is 580 feet above sea level, to the beginning of the trail, which is 200 feet below sea level. What is the vertical distance between 580 feet above sea level and 280 feet below sea level? So we can show this on this number line. So let's just like visualize this. So I'm going to put 580 up here, and then 200 feet below sea level, and it's going to be negative down there. So before lunch, they went from here up. After lunch, they went from here down. What is the vertical distance between 580 feet above sea level and 200 feet below sea level? We can do that using the same distance formula, and it's not really going to change. Like, you can probably guess right now that it's going to be the same answer, but just for the sake of practice, we're going to do it anyway. 580, absolute value of 580 minus negative 200. That we're going to change to an addition problem. So keep 580, add opposite 200. Absolute value of 780 is 780 feet. We can show this by this addition problem here. So the absolute value is the distance between a number and 0. So this distance here is 580. And this distance here is 200. So it doesn't really matter like what order we put them in. So when we add 580 and 200, that's when we get 780. Okay. What is the change in elevation? So the change in elevation, when the hiker was going up, the change in elevation was 780. But at the beginning of this problem, it said that a change in elevation can be positive or negative depending on if it's increasing or decreasing. And after lunch, the hiker hiked back down the mountain, so that change is negative 780 feet. Okay, we're gonna skip exercise 3 for now, and most of exercise 4. In exercise 4, we're gonna go down to letter D in exercise 4. So Beryl is the first person to finish a 5K race and is standing 15 feet beyond the finish line. Another runner, Jeremy, is currently trying to finish the race and it has approximately 14 feet before he reaches the finish line. What is the minimum possible distance between Burl and Jeremy? So let's draw this out just so we understand what's exactly going on here, okay? So we've got our racetrack here on our little number line. We can make it nice and detailed, whatever, that's cool. And we've got our little finish line. Yay, finish line. To make it simpler, I'm actually gonna draw a finish flag. Yay, finish. Okay. Our buddy Burl here is 15 feet beyond the finish line. So I'm gonna call the finish line 0, and I'm gonna draw old Burl right here, and he is 15 feet past the finish line. Jeremy is trying to finish, and he is approximately 14 feet before he reaches the finish line. So he's before, in this direction, he reaches the finish line. So let's draw him right over here. He's running, he's trying his hardest to catch up to Burl. And what did they say? 14 feet before the finish line. So we're gonna label this as negative. What is the minimum possible distance between Burl and Jeremy? So we're talking about distance. So let's write down our distance formula. We've got the absolute value of P minus Q. And let's solve this. So P, we're gonna call, because we talked about Burl first, we can call P 15. And Jeremy came second. We're gonna call Jeremy's location Q, and that's negative 14. And these are both in feet. So let's take the absolute value of P, which is 15, minus negative 14. This is equal to 15 plus the opposite of negative 14 is just 14. And this is a simple addition problem. 15 plus 14 is 29. Absolute value of 29 is 29 feet. So the minimum possible distance between Burl and Jeremy is 29 feet. They are approximately 29 feet away from each other. And this is positive because distance is always positive. Okay, now for your homework, even though all of you are already at home doing work, I would like you to work on this on the problem set problems. Use on page, what page is this? 38. Using the distance formula, absolute value of P minus Q. Okay. So do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And when you are finished, check Schoology for a notes check mini quiz or discussion question. And the next time I see you, we're going to talk about this problem set in class.